This lesson goes over how to find the x and y intercepts of an equation and then how to use them to graph the equation. First, we need to remember, what are the intercepts? Intercepts are defined as the points where a line crosses an axis. So here's a line, this particular blue line. It has some equation that goes with it, although I don't know what it is. And here's that line shown against a coordinate axis. Notice that this blue line crosses the x-axis here, and we call that point the x-intercept. It crosses the y-axis here, and that point we call the y-intercept. So the intercepts are just the points where the line crosses each axis. Now we need to know what's about points that lie along these axes. And yes, that is the word axes, it's the plural of axis. So first, let's look at the x-axis, and let's examine some points along the x-axis. Here's one. It has the coordinate 1, 0. Next is 2, 0, and then 3, 0, and then 4, 0, and then 5, 0. We notice that for all of the points on the x-axis, the x-coordinate has some number in it, and the y-coordinate is always 0. In general, a point on the x-axis will have the form x, 0. Since the x-intercept is a point on the x-axis, it's going to have the general form x, 0. In this case, this particular x-intercept happens where x is 2. So this x-intercept is 2, 0. Next, let's look at the y-axis and see what's special about the points in the y-axis. This point is 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. We notice that for all of these points on the y-axis, they have the general form 0, y. So the y-intercept, since it's one of these points on the y-axis, will have the general form 0, y. For this particular line, the line crosses the y-axis at 0, 3. So 3 is the y-intercept. Now you try. Pause this presentation for a moment and identify what are the x and y-intercepts for the purple line that's shown here. Please label each one so that when I ask you, hey, how did you figure that out, you can tell me which intercept is which. So label one the x-intercept and the other the y-intercept, and list both of their coordinates. Next, let's see if you can graph a line just by knowing its intercepts. Suppose that I told you that there's a line that has an x-intercept of 5 and a y-intercept of -3. Is that enough information to graph the line? Well, it is. You would find that if you plotted the x-intercept of 5 on the x-axis and the y-intercept of -3 on the y-axis, you'd have 2 points that you could connect together to make a line. Go ahead and do that and resume the presentation when you're done. Now let's look at what intercepts look like if we place them in a table. We said that the x-intercept has a general form x, 0. So if we were to find the x-intercept in a table, there would be some number in the x column and a 0 in the y column. We said that the y-intercept has the coordinates 0, y. So if we were to find the y-coordinate in a table, it would have 0 for its x-coordinate and some number for its y-coordinate. Then, let's see what these intercepts look like in an equation. First, let's start with the equation of a line that's in slope-intercept form. So in this case, slope-intercept form, y equals 2x plus 3. One thing that's nice about this is we can quickly spot the y-intercept. We remember that slope-intercept form, y equals mx plus b, the plus b part, the constant in the equation, is our y-intercept. So we can tell the y-intercept just by looking. So we know that the y-intercept for this particular equation is 3. To find the x-intercept, we have to do a little work. It might be tempting to simply say that the x-intercept has to be 2, because that's the only other number you see in the equation. But that isn't right. Let's see why not. If we start with the equation y equals 2x plus 3, we know that our x-intercept has to have 0 in place of y. It has to be the x that balances out a 0 of y. So let's rewrite our equation, replacing the y in it with 0. And now let's solve it for x to see what value x has to have to make our equation balance. To do that, first, we'll subtract 3 from both sides, and that'll give us negative 3 equals 2x. And then we'll divide both sides by 2, and that'll give us x equals negative 3 over 2, or negative 3 halves. So notice that this isn't a number that we see anywhere just by looking at the equation. We do have to plug in 0 for y, and then find the x-intercept that way. So the x-intercept now is negative 3 halves. This is a little bit of work when we start in slope-intercept form, but it can be easier to find the intercepts. Start with an equation in standard form. So in standard form, the x and the y are on the same side of the equal sign. Here's an example, 2x plus 3y equals 6. And it's quite easy to find the x and y intercepts in this case. First, let's find the y-intercept. We're going to plug in 0 for x and y for y, and we're going to solve for y. What makes this easy is that 2 times 0 is just 0, and 0 plus 3y is just 3y. So very quickly, this becomes a simple one-step equation, 3y equals 6. That's a one-step equation that I can do in my head, and I know that y has to be 2. So my y-intercept in this case is 2. Finding the x-intercept is just as easy. We'll take our equation, and we'll replace x with x, we'll leave it that way because that's what we're trying to find, and y with 0. Again, 3 times 0 is 0, and 0 plus 2x is just 2x. So now I have a one-step equation, x equals 6. I can divide both sides by 2 and find that x has to be 3. So the x-intercept is 3. So that was a pretty easy way to find both the x and y intercepts. Why is this helpful? Well, use the x and y intercepts to graph an equation. Here's an example of another equation in standard form where we can quickly find the x and y intercepts and use them to create the graph. When I plug in a 0 for y, I get that x has to be 4, so there's my x-intercept at 4, and you can see that here. When I plug in a 0 for x, I find that y has to be 2, so 0, 2 is my y-intercept, and you can see that point here. The line that goes through those 2 points is the graph of the equation x plus 2y equals 4. It's a simple and quick way to graph that equation. Now you try. Pause this presentation while you find the x and y intercepts of the equation shown, 2y plus 5x equals 10, and then use those 2 points, that x and y intercept, to graph the equation.